Hello, dear friends. Today we will discuss the concept of vector and scale. Unit number one or unit number seven of second year mathematics. Unit number seven, we will discuss the two major concepts of scalars and vectors. First of all, we will discuss the concept of scalar. After that, we'll discuss vectors in detail. So first of all, scalar. What is scalar quantity? Before starting the definition of scalar quantity, we should need to define uh, physical quantities. And physical quantities are defined as those quantities which are to be measured. I mean, whose measurement is possible. Such type of quantities are called scalars. For example, we can measure the length of cloth, or we can measure or mm, uh, vegetables. There are instrument to measure their length in kilogram and centimeters, meters. So many quantities are there which are not measurable, like wisdom of any person cannot be measured, its intelligence cannot be measured. These are the types of quantities which are not measured, but we are not discussing those quantities which cannot be measured. We are discussing only those quantities which we can measure. So those quantities which can be measured, these are called physical quantities. Now we come towards the concept of scalar. So scalars are those physical quantities which have magnitude only. Scalars are physical quantities. It means that scalars are those quantities which can be measured, and those quantities which have magnitude only. Magnitude only means magnitude definition is that a number along with its unit. A number with its unit is called magnitude. So whenever we say we are going to buy 2 kg vegetables, then 2 is the number and kg is the unit in which we measure the vegetables quantity. So this is an example of magnitude. Next, if we are covering a distance of 5 kilometers in 1 hour, then 5 kilometer, 5 is the number and kilometer is the unit in which we are measuring the distance. So this is also a magnitude. So a physical quantity which has magnitude only, this is called a scalar quantity. So first example is time, second one is volume, third one is speed and work. uh, Besides this, also speed is a scalar quantity, distance is a scalar quantity. So these are the quantities which has only magnitude, so they are called scalars. Next, uh, we will discuss how scalars are denoted. Scalars are denoted by simple letters, A, B, C, A to Z. Alphabets can be used to represent scalars, but a little difference is in the definition of scalars and vectors. Vector is a quantity. First of all, it is a physical quantity. So physical quantity, we have already discussed that this is a quantity which can be measured. So those physical quantities which has two things. Number one is their magnitude and number two is their direction. This is called vector. Examples of vectors include force. Whenever we apply a force on a certain object, then it moves from one place to another. So note that we apply some force. Suppose we have applied a force from left hand side, 5 Newton. So 5 Newton is our force, and whenever we apply force, we should tell its direction. So direction may be from left to right, top to bottom, or above to below, or below to above. So this is direction. So the difference between scalar and vector is that scalar is a quantity which has magnitude only, but vector is a physical quantity which has both magnitude and direction. Now look at this, the examples of scalars and vectors. So scalars examples include speed, volume, time, and work. But in case of vectors, vectors are the quantities which has magnitude and direction. So first of all, we will discuss its example. This is velocity. Velocity, displacement, acceleration, momentum. These are the quantities which are vector because they have both magnitude and directions. As we have already discussed that how scalars are represented. So scalars are represented by simple letters. But whenever we are going to describe the vector, then we put an arrow above it or below it, or bold-faced letters to represent a vector. This is the distinction between representation of vectors and scalars, that scalars are represented by simple letters and vectors are represented by the letter by putting an arrow or below a line. So this is very easy. Next, we discuss the geometrical interpretation of vectors. So how vectors are represented geometrically, graphically. We can discuss this concept easily. Geometrically, a vector is represented by the line segment AB with A its initial point and B as its terminal point. This is very easy. Suppose we have a vector AB. We represent the point A to B. A vector we want to make. So A is called the initial point and B is called terminal point. It is often found convenient to denote a vector by an arrow, and it is written either as AB vector or bold-faced letter like this one, or in underline form. So there are three ways to represent a vector: by putting an arrow above it, or by putting a line below it, or by using bold-faced letters. So this is very easy. So this is known as geometrical interpretation of vector. This is nothing but just the representation of a vector. Here we tell how a vector can be represented. There are three ways: either by putting an arrow on it, or by a simple letter, a bold-faced letter, or by putting a line below the letter. So this is the geometrical interpretation of a vector. Next, we are going to study the magnitude of a vector. So what is the magnitude of vector? Let V be any vector. Suppose that we have a vector and this is vector is V. We are calling them V. Then its name may be other than V, U, W, etc. You like to say, it's up to you. Then its magnitude is denoted by, this is our vector, and by putting these two lines represent the magnitude of a vector, or simply V. If we do not put these two lines, then we have to remove this arrow or write simple V. This is the representation of magnitude of a vector. uh, Note that these two lines means magnitude or norm. In higher classes we called it norm, but in this class we call magnitude. But here point to be noted is that in 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 case of matrices, when we put these two lines, it means determinant. But here it means uh, this is the symbol of magnitude. Whenever we are discussing 2, 3, 4, 5 numbers, in case of numbers this is our determinant, but in case of vectors this is magnitude of a vector. So next, this is called norm. Its other name is length of a vector. So here note that uh, one person can have two or more than two nicknames. So similarly, vectors have more than two names. Here we are considering the definition of magnitude of vector. So magnitude of vector has more than one name. It is also called length, it is called norm, or simply it is called magnitude. So it's up to you what you name you want to call it. So this is very easy. Distance, it is the magnitude of a vector is nothing but it will be, if the vector AB represent a vector, then distance from point A to B will be the magnitude of AB, and it is denoted by AB vector. Here